Isotropic and anisotropic are two contrasting adjectives and nouns used to describe the properties of materials and minerals. Both isotropic and anisotropic also contain the element of direction in their descriptions. Isotropic and anisotropic are related words that are opposite of each other, an adjective that describes something with identical properties in all directions. As its opposite, an isotropic also serves the same purpose as a noun and adjective for material with different properties in all directions. Isotropic is independent of direction, while anisotropic materials are highly dependent on the direction.
Amorphous solids are said to be isotropic, and crystalline solids are said to be anisotropic for their physical property measurement.
Isotropic comes from the Greek word iso, which means same, and tropos, which means direction or weight. The name rightly indicates that for the amorphous solid, the physical properties measured are same in all of the directions.
The same correlation applies for anisotropy, that means no same direction. It means that for the crystalline solid, the physical property measurements are not same in all the directions.
The physical properties that depend on direction for taking measurements and therefore affected by the nature of the solid are refractive index, electrical conductivity, thermal conductivity, photoelasticity, and many more.
For the crystalline solid, the arrangement is ordered and periodic. What it implies is that if physical property measurements are taken along the x-axis, its reading will be different than it measured from another axis, say y-axis or the z-axis. Different direction will give different measurements, but this is not the case with amorphous solids. For the amorphous solids, same values will be obtained irrespective for the direction of the measurement.
Material can be considered as anisotropic if it allows sunlight to pass through it. The material's upper polar system allows light to pass through. In truth, it affects the polarization of light. The velocity of light is also different, and there is double refraction, which means the light is split into two directions. Anisotropic minerals can be penetrated by light due to their inconsistent properties in all directions. Chemical bonding is another point of difference. Anisotropic minerals have different and inconsistent chemical bonding. In anisotropic minerals have the characteristic of double refraction, which can be classified as uniaxial, which mean one opposite axis, or biaxial, which is two axes. Anisotropic materials are often found in different fields like computer graphics, chemistry, physics, geography, and geophysics.
An isotropic mineral can appear or remain dark when light passes through it. The uniform structure of the mineral blocks the light from all directions. In addition, light does not affect the mineral's polarization or the direction of the light. The velocity of light is in all directions, and the index of the refraction is everywhere.